As Mendeleev gave some vacant places in the periodic table, he named those places as Eka boron, Eka aluminium and Eka silicon. Let's have a look. See, Eka boron, Eka aluminium and Eka silicon. These names were given after the neighboring elements, the known neighboring elements. And he also predicted the physical and chemical properties of the undiscovered elements. Later on, when the elements were found, these were named as scandium. That means the place of Eka boron was taken by the element scandium, the place of Eka aluminium was taken by element gallium, and the place of Eka silicon was taken by element germanium. Let's have a look at this table. When Mendeleev left a vacant place and named it as Eka aluminium, he also predicted some of the properties. You can see the atomic mass into the first column, and he predicted that the atomic mass of that undiscovered element can be 68. And when gallium was discovered, it was found that the atomic mass of gallium was 69.7, which is nearly equal to 68. Then he also predicted the density of that undiscovered element as 5.9, and the actual density of gallium was found 5.94. Hope you know what is the meaning of density. Density is the ratio of mass and volume. Melting point, he predicted that the melting point is going to be low of that undiscovered element, and the melting point of gallium was found 30.2 degrees Celsius. The formula of chloride of that undiscovered element was predicted as ECl3, and the formula of gallium chloride is GaCl3. Formula of chloride means whenever that element will react with chlorine, it will react in such a way, and the general formula is going to be ECl3, and the actual formula of gallium chloride is GaCl3. In the same way, formula of oxide, gallium oxide, Ga2O3, and he predicted that the general formula of that undiscovered element is going to be E2O3. Then the nature of oxide, how that oxide is going to be. Generally, oxides can be basic or acidic. All the metallic oxides are basic in nature, while all the non-metallic oxides are acidic in nature. But gallium is such a metal which shows amphoteric oxide. Hope you know what is the meaning of amphoteric oxide. Amphoteric oxide can also act as a base as well as an acid. That I will show you in my next video. Then let's turn towards the third merit of the periodic table, of Mendeleev's periodic table, and he left some reserved place. There was no reserved place for the noble gases, and later on when the noble gases were discovered, he did not touch his already made periodic table, but he made a separate group for all those noble gases, and he placed all those noble gases such as helium, neon, argon, krypton, xenon, radon into a zero group, into a separate group. So this periodic table was not disturbed by Mendeleev, and that this is also one of the merit of Mendeleev's periodic table. Now let's move towards the demerits or the limitations of Mendeleev's periodic table. In simple words, the demerits of the Mendeleev's periodic table are the whole number atomic mass of elements cobalt and nickel is the same. Therefore, there was an ambiguity regarding the sequence in Mendeleev's periodic table. Ambiguity means unclearness. That means that things were not clear because the whole number of the atomic mass of cobalt and nickel was one and the same, and the Mendeleev's periodic table was based on atomic mass. So where he could fit both the elements with the same atomic mass. So this was one of the demerit. Then isotopes also have no place into the periodic table, because you know what is the meaning of isotope. Isotopes are the atoms of the same element with same atomic number but different atomic mass number. As Mendel's periodic table was based on atomic mass number, isotopes could find no place in the periodic table. When elements are arranged in an increasing order of atomic mass, the rise in atomic mass does not appear to be uniform. It was not possible, therefore, to predict how many elements could be discovered between two heavy elements. I'll show you how. Now see, there's a difference. This is tin, Sn, and this is antimony, Sb. The atomic mass is 118 and that of antimony is 122. So he could not predict that how many elements. Now there's a difference of how many units from 118 to 122, difference of 4 units. So he could not predict that how many elements could be fitted between tin and antimony. So this was also one of the demerit of Mendeleev periodic table. Even the position of hydrogen was not fixed, because you can see that hydrogen is placed in group 1 and it shows some of the properties similar to that of sodium, lithium, potassium and whatever elements are placed into group 1, but it also resembles some properties with the halogens. For example, hydrogen is a diatomic molecule in the same way hydrogen is a diatomic molecule. Even halogens are diatomic molecules. These are known as halogens. Fluorine, chlorine, then bromine, these are also halogens and these are also diatomic molecules. Then whenever